Hi, I'm Chad Hart, and this is Reed Steidoff, and we're with Acme Packet. Acme Packet makes software and infrastructure for real-time communication session delivery across disparate networks. We've been focused on this problem for a long time. Many of us might know of us for our session border control product, which is basically a product that provides security, reliability, interoperability, and regulatory compliance. And as I mentioned, we've been doing this for 10 years. We have a very large and diverse customer base that varies from some of the largest companies in the world to small development shops. Includes traditional PSTN service providers, internet service providers, enterprises, contact centers, even government agencies. Organizations you might know of like Verizon, Skype, ADP, State of Delaware, just to name a few. And real-time communications over the web is something that's actually not new to us. This is we've had customers in production using web-based RTC methods for more than 5 years, and we're very excited about WebRTC. So, what does Acme Packet do exactly? We like to describe ourselves as bridging islands. Now, historically, a lot of these islands were within or between service providers, whether PSTN providers or internet service providers. This can also be between service providers and businesses, or within businesses, or their contact centers. But the opportunity that we're really excited about is bridging islands to the huge continent of the more than 2 billion internet users out there via the web. And with that short intro, I'll hand things over to Reed to run through our demo.
Hey guys, Reed Steidoff here. I am a solutions architect at Acme Packet. So the basic demo setup that we're going to show is pretty straightforward. Here's a diagram that shows 3 main components of the demo. Number one, a standard web server. For those that are interested, it's a Linux Apache MySQL server running in AWS, Amazon EC2. And then we have behind this the PSTN. We're connected via a SIP trunk back to the PSTN infrastructure, and its millions of users and numbers. And then tying it and gatewaying it together is a piece of Acme Packet technology bridging that divide and providing interworking. So it's worth noting that, so if we look at this diagram, while this is a SIP trunk to the PSTN, what Acme Packet is focused on is making this technology work with virtually any SIP infrastructure and any web infrastructure, providing sort of a middleware layer between those 2 disparate realms or worlds, if you will. So, you could exchange that out for an IMS core. Actually, we did a press release today describing a integration with a third-party IMS core at a large Tier 1 service provider, a wireless service provider, where we took essentially a WebRTC-based client and integrated that, again, with third-party web infrastructure, third-party IMS infrastructure, and provided a security element and an interworking element in between those. So it could be an IMS core, obviously it could be PBX, enterprise UC application servers, things like that. So you get the idea. SIP on one side, gatewayed to WebRTC on the other side. So our first application, we're going to show a couple specific demos of applications, but again, us as Acme Packet, we tend to focus on the hard security or the hard problems of session delivery, things like scaling media, security. It's peer-to-peer applications are really cool. You can do them lightweight from a server-side processing perspective, but when you get to the point where you're needing to handle line rate encryption, at gigabits or 10 gigabits per second speeds, doing SRTP encryption, ICE negotiation, all that. We're focused on a lot of those large-scale problems with our hardware platforms. So while we we've seen some great applications up here. Acme Packet tends to be that security and infrastructure piece. Typically not, engineers find that stuff sexy. It's not the
dirty plumbing.
Yeah, it's the plumbing. So this is a plumber's attempt at a few applications here, but showing leveraging that signaling channel for application providers. So let me switch. The setup for this one, again, this envision an IMS service provider or a wireless service provider with an IMS core. They all have a web page typically today. They have user portals where they're able to log in. So imagine this white space is that user portal where, yeah, let me move this over here. So imagine the user portal, the white space is the user portal. Customer logs in, they got their account details here, and for whatever reason their phone is not on them, or it's just more convenient to use the browser when they need to make a call, so activate a widget served in the web page with them. This particular one, since it's served in my account portal, it knows my device, and it serves me a fully functional HTML5 version of my device here, and fully functional to the point I can actually make a call. So I've got a number here. We will demonstrate a live PSTN call, again, using the demo setup described. So again, it's worth noting that the look and feel and the application experience should be done by web developers. Ultimately, they're going to be the best at integrating that experience. So, and there we have a phone call to my buddy. Yeah, answer the phone.
We have
got
audio?
audio in the...
Audio?
There we go. So, anyways, this, like I said, the experience that we've come up with an experience here, but our idea and our vision is that the web developers would ultimately be able to leverage the RTC cores that exist today, and be able to also leverage the tenets of the web. The web is an awesome place for innovation, application creation, and leverage that core and weave RTC into those experiences while leveraging the users and the infrastructure that's in place. Another scenario here, this is one that's often talked about, is the support happy button. This uses the exact same infrastructure. Nothing too fancy here, but IT help desk has a little self-help page. Have you tried turning it on and off again? Is the button on the side glowing, perhaps? Is it working now? Okay, so you've exhausted your options, nothing's working, and click the button to speak to support. Those that are IT crowd fans, there you go. So hopefully Moss or Roy is on the other end of this, and it rings through to allow the call. Anyways, again, nothing too sexy about the application there. But you get the point of leveraging existing signaling channels that are in existence and extending those to the web. So when we look at WebRTC, we see there as being a big technology divide between the traditional infrastructures and the web. And ultimately, there is really good technologies on both sides of that. The WebRTC ultimately is a media engine for both of them. It's for pure web. It's for traditional real-time communications providers. And we see ourselves in this sort of technology providing what we often consider a service reach aspect of a session delivery network. So the ability to span that technology divide with little to no changes to your core infrastructure and extend it into the web to offer any number of services from the companion clients to the call center applications and so on and so forth. So, in the future, obviously the pure web players will be doing peer-to-peer to begin with, but as there becomes increased scale demands on things like compliancy, things where they're going to need to, on server side, handle large amounts of media, we see great uses for our technology and our platforms in those places as well. So that's the demo. Thank you.